So a few comments. There will be a question on your test on the multiple choice section where I ask you to find FC. Here's what I really mean. If I say find the centripetal force, you can go straight to that or that, no free body diagram required. There will be a multiple choice question where in this question there's 1, 2, 3, 4 variables. I'll give you 3, find the fourth. So I'll either give you FC, M, and R and say find V, or I'll give you FC, M, and V squared and say find R, or I'll give you M, V, and R and say find FC. Or in this version, I'll give you 1, 2, 3, 4 variables, 3 of those, find the fourth. And you'll know in the same way that last year FNet said you go straight to MA without a free body diagram. If I say the centripetal force is, I've done the free body diagram for you, you can go straight to FC equals MAC, whichever version it is. So there's going to be one of those on your multiple choice test. And let us jump in. Number 1, how fast is it going? I think this is going to be a job for a free body diagram because they gave me a coefficient of friction. Now, I can find how fast by going 2 pi r over the period. They gave me the radius, but they didn't give me the period, so I think I'm going to have to do a free body diagram. This is for a car going around a corner. We said the key for that was to do a good free body diagram. What I said was a front view worked the best. I drew something like that. You don't have to draw the car, you can just put a dot there. And then I often even drew a little arrow like that saying that's how we're going around the corner. What are the forces acting on this? Get the obvious one. I have gravity down. Normal force up. What path is this car tracing out? Where must there be an unbalanced force pointing? Never FC. FC never shows up on my free body diagram. What's pushing me in a circle? Friction. And so all of that to get to friction is what's pushing me in a circle. Which version of M am I going to use? I think I'm going to use the one with the V in it because they asked for how fast. Friction is mu times the normal force. I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. I can go mu mg equals mv squared over r. Can little cars and big trucks go on this road? Why? Well, that's helpful. And they want me to get the v. Oh, it's our old friend, the square root of GER, with some other stuff. Mu GER. And so I think when I solved this one in my block A's, Mr. Dewick, what did I get? You get 13.9? Okay. If you got that, I would give you 3 out of 3. Otherwise, I noticed I did 6 steps to get there, so a half mark for each step is probably what I would do. Number 2 was kind of a similar question to number 1. In that we have something going around a circle, and I'm pretty sure friction is what's pushing us in a circle. But I didn't have to use a free body diagram to find the speed. I noticed here they gave me r and t, and that equation is on your formula sheet. You don't need to memorize it. It's going to be 2 pi times 0.19, not 19, nice try, Mr. Dewick, divided by 0.682. This t is not squared, and I'm going from memory. Do you get 1.75? Is that the answer? Yeah, meters per second. Okay. Then B is going to be the same free body diagram as the car going around a corner, except it's going to be a spider, but it's going to be, again, gravity down, normal force up. Again, friction is what's pushing me in a circle. But this time, I said, I guess I'm going to use the 4 pi squared r over t squared. I could have used v squared over r and used my answer from part A, but Alicia, I have a habit, if I can avoid using an answer to find an answer, I'll try and do that. And since they gave me the period, I used that one. And I got mu times the normal force. I don't know the normal force. It turns out the mass of the spider here canceled, if I recall. And I ended up with mu being 4 pi squared r over gt squared, because stuff moves diagonally. And I ended up with a coefficient of friction, a fairly big one, but that's why I wrote in brackets, a spider has sticky feet, so it can have a mu bigger than 1. It's having to grip. Then we come to the gravitron. Oh, on your written section, almost certainly somewhere, I will ask you to draw a free body diagram for one of these things, because that's also, I think, valid, because you've noticed our free body diagrams, we're tweaking them because we know we're moving in a circle. So a person is riding the gravitron. The key here, if that's the wall of the gravitron right there, there's the person. Well, I know this person is tracing out a circle, so I know there has to be an unbalanced force that way. I'll come back to that. But is this person accelerating down? What are the forces acting on him? Get the obvious one. If they're not accelerating down, there has to be a force up. And this is the weird thing. You have to realize normal force is what's causing the fake gravity. Friction is what's keeping us from sliding down. As an equation, we're going to get this. Normal force is what's pulling us or pushing us in a circle. They gave me the period, so I'm going to use the m4 pi squared r over t squared, and I don't know the normal force. It's not mg. But what I can do is write a second equation. I can write a vertical force equation. And the vertical force equation says mg equals friction. It says mg equals mu times the normal force. Now I have a choice. Deegan, if you wanted to, you could move this expression for the normal force and stick it right into there. And you'd have mu m4 pi squared r over t squared. I have a habit of getting the normal force by itself. I usually do that, and then I stick this right to there. Either of those approaches, you'll get full marks. My answer key will have both done. But I put that there. When I did that, I ended up with mg over mu equals m4 pi squared r over t squared. Can little kids and grown-ups go on this ride? Well, that's kind of cool. I ended up with r, to get the r by itself, stuff moves diagonally, gt squared over mu 4 pi squared, and I ended up with a radius of 5.65 meters. If you got that, I would give you 7 out of 7. If you did not, then here is how I would do the part marks, something like that. Any lawyering with me? Now is the time. Otherwise, can you give yourself a clear score, please, out of 15, please?